This is 5.1, derivatives of natural logarithms. Basically, this is a pretty simple concept. Obviously, you may need some refreshing on prior knowledge about natural logs, but the derivative of a natural log is always going to be 1 over x. Now, when we see natural log of x, basically the way we're going to look at this is the basic derivative will always be 1 over. Okay, but what's going to happen is whatever the derivative of the inside is, that's going to be what goes on top. So we're essentially using the chain rule on this, but all basic derivatives of natural logs will be 1 over. And then, like I said, when it's something other than x, that's when we might get something a little bit different. So it says find the derivative of y equals ln of x. Well, that's just simply y prime equals 1 over x. Basically, what we're going to do is we're going to say that the derivative of a natural log function is going to be the derivative of whatever you're taking the natural log of, in this case 1, over what you're taking the natural log of, 1 over x. Okay, so let's look and see what happens when we go to this problem right here. So now it's not natural log of x anymore, it's 5x squared minus 3x. The big mistake that students make here is they just think, oh, this must be y prime must be equal to 1 over 5x squared minus 3x. And that's not right. Okay? What's going to happen is the 5x squared minus 3x is definitely going to be on the bottom, but on the top is going to be whatever the derivative is. So it's like the chain rule. The outer portion is going to be 1 over whatever we started with, and the inner portion is whatever the derivative of 5x squared minus 3x is. So the actual derivative just ends up being 10x minus 3 on top, and then 5x squared minus 3x on the bottom. And that's it. So derivative of the inside over the original on the inside is always going to be the derivative of a natural log. So let's get into this a little bit more. This is pretty basic, pretty straightforward, but let's get into where natural logs and logarithms can help us a little bit more with derivatives, and that's going to be on the back side. And some of this is going to require you to remember some of the properties of logarithms. So we have 4 properties here that are important. The first one is knowing that the natural log of 1 is always equal to 0. That's the first thing. The second thing is the natural log of 2 things multiplied together, so that's a times b, is the same thing as saying the natural log of a plus the natural log of b. What we're doing is we're separating the a and the b into addition. So if you see multiplication, it means that we can add 2 separate natural logs. If you have an exponent, natural log of something to an exponent, we can bring that exponent out front. So this n would come out front. It would be n times the natural log of a in this case. And then if we have division, a quotient, it's subtraction. So this would be ln of a minus the ln of b. So how does that work? Well, for this first derivative that we're seeing, the idea of this is that we can take this derivative without doing the product rule. Technically, you could use the product rule, you know, the derivative of the inside over the original, but we don't need to. What we can do is we can just separate it into 2 functions. So we're first going to rewrite this as y equals the ln of x. Remember, this is multiplied, so therefore we're going to separate it into 2 natural logs. The ln of x plus the ln of cosine of x. Now we can take each one of these derivatives separately. The derivative of ln of x is just 1 over x. The derivative of ln of cosine of x is just going to be, the derivative of cosine is negative sine of x over the original, which is just cosine of x. So if we were to finish this off and really simplify this, it would be 1 over x, and then this minus sign, sine over cosine is actually equal to tangent, so it's just 1 over x minus tangent of x. So that's what our y prime would be here. Okay, so again, if you see that you can break up your natural log into a few functions so it's easier to take the derivative, then that's what you want to do. So this one, while it seems like it might be really complicated, it actually isn't once we understand how to separate everything. So what I'm going to do is I'm going to rewrite this notice we have a multiplication of functions on top, okay? We have a division on the bottom. So I'm going to separate this one by one. So the multiplication of these two things, this would look like, and this may take a couple steps for you to see this. So this is going to be ln of x plus the ln of x squared plus 1 squared minus the ln of the square root of 2x to the third minus 1. So what we need to look at now is look at exponents. Can we bring any of the exponents down? So hopefully you'll see that the square root, this can actually be changed to the 1/2 power. So I'm actually going to change this 2x to the third minus 1 to the 1/2 power. And now I'm going to rewrite it one more time. So we have ln of x plus, the 2 is going to come out front because that's what the exponents do, minus the 1/2 is going to come out front. And now if you notice what we have all much easier derivatives to do here. So we can do the derivative as y prime equals ln of x is 1 over x. We got that. Plus, then we have a 2. We'll worry about the 2 at the end. I'll multiply that in at the end. But we have the derivative of the top, which is going to be 2x. And there's my 2 that I left on the outside there. 2x on top, and then x squared plus 1 on the bottom, minus, and again we're going to leave the 1/2 until the end, we have 6x squared on the top. And remember, we have the 1/2 out front here, so that means we have a 2 on the bottom times 2x to the third minus 1. So the only thing left for us to do would be to potentially simplify this into our final answer, and that just means we're going to multiply through what we can. So we have 1 over x plus 4x over x squared plus 1 minus 6x squared over 4x to the third minus 2. And that's it. So the goal of some of these problems is to first break them down, separate the logarithm so it's all single terms that we can take the derivative of without doing chain rule, without doing product rule, things like that. It makes it a whole lot easier to do this. So hopefully that makes sense. I know that the back page might be a little bit more difficult than the front page, but bring questions to class. If there was an Edmodo quiz assigned, then make sure you do that. I will see you then.